So we're going to talk about the chain rule today. Remember Thursday, we don't come here for class. I'm going to give you a handout today to work on for Thursday. You don't have to go to study session either. So you get a chance to sleep in a little bit. I do have the test, but I'm going to hand it back near the end of class so that you don't just look at that the whole time. So we're going to talk about the chain rule today, which is section 4, chapter 2. And the whole idea behind the chain rule is that we're going to deal with more complex functions, but which are composite functions of functions that we already know the derivative for. So here are some examples. Let me put a little screen up there so you don't get... Where's my screen? Here it is. So instead of having x to the 7th power, which we know how to take the derivative of, and x squared plus 4x, which we know how to take the derivative of, this is x squared plus 4x, the quantity raised to the 7th power. So the question is, how do you deal with problems like that? So basically, well, actually, let me see if I try to remember what I did here. Yeah. So let's see if I'm just doing a quick review here of what I need to do. Okay, well, I guess that was pretty much okay. That was fine. Okay, so the basic idea is how do you handle these composite functions, and so I'm just going to teach you the technique, and then I'll explain what is involved. So what you do is you break it up into the two parts of a composite function. So it's going to be, what you normally have is a composite function is f of g of x. So you have the, you should have covered this in pre-calculus. Let me just open up another page here. So if you remember, composite functions were f of g of x. And in our particular case, what we have is we would say g of x is equal to x squared plus 4x, and f of x would be equal to x to the 7th power. So what you do in a composite function is you substitute this function in for the variable. So f of g of x equals x squared plus 4x to the 7th power. And you guys mostly talked about it from, talked about the domain and range, and how the domain of, you're looking at really the domain of this internal function instead of looking at it as the final function. But we don't worry too much about that. We're not going to worry about that. What we're worried about is how do you take the derivative of that function, because I could multiply this out using FOIL 7 times, but that would be a huge chore. So that's not what we're going to do. Okay. So what we do is we're actually going to do it instead of f of g of x, we're going to call it f of u of x. Okay. I don't know why, but we do. So the first thing we're going to do is identify what the internal function is. I'll call it internal, because it's usually something that's in parentheses. So in our particular case here, that is, we would say u of x equals x squared plus 4x. And then you kind of identify the outside function. So we identify f of u. Okay. So that's the function that if I replaced u of x, this with u, So if I replaced in the original equation in f of x, I'd have u of x, basically u of x to the 7th power. So we would say f of u is just u to the 7th power. So we use a u instead of u of x, just kind of as a shorthand arrangement. So that if I take u of x and I plug it into here for u, I'll get back to my original function. Now the chain rule, so 3 is write down the chain rule. Which it says that f prime of x equals f prime of u times u prime of x. So what I'm going to do is I'm going to take the derivative of this function with respect to u, and I'm going to multiply that by the derivative of the internal function with respect to x. So I just treat this like a normal formula. I can still use the power rule formula here, but I would just, instead of being x to the 7th, the derivative would be 7x to the 6th. It's going to be 7 times u to the 6th. So I need to be able to do that. I need to calculate both f prime of u, and so let's put calculate. Calculate f prime of u and u prime of x. So, and these all have to be, the functions that I end up with here have to be something that I could take the derivative of, just like I did the other day. So f prime of u is just going to be equal to 7u to the 6th power, using the power rule. And u prime of x is just going to be, again using the power rule, 2x plus 4. So I take the derivative of each one separately. And it's called the chain rule because I'm kind of chaining these derivatives together, connecting them. So to get the total derivative, I take the derivatives of parts of them and then multiply them together to get the final derivative. So the 5th step is to substitute f prime of u and u prime of x into 3, which means into this equation here. So that means, that says that f prime of x, which is the derivative of the composite function, is 7u to the 6th, which is f prime of u. So I'm plugging that in there, times, and I'm going to put parentheses here so that we make sure we multiply it by the whole thing, u prime of x. The problem with this is that I want the derivative in terms of x, but I've got it in terms of u and x. So to be able to rewrite this entirely in terms of x, I go back to what I defined u to be up here, right there, and plug that in. So the next step is substitute u equals x squared plus 4x from step 1. So then that becomes f prime of x equals 7 times x squared plus 4x to the 6th power times 2x plus 4. And then I'll say simplify and rearrange. So there's really not much to do to simplify in this case, but what I would do is I would take this part, move it to the front. It kind of has a pecking order as far as what goes you typically have your most complicated stuff at the end of your expression. So all I've done is just move that here. And that's why you got to don't be stingy with parentheses. Because if I didn't put the parentheses here, I'd have 7 times 2x, and then plus 4 times that, instead of knowing that I multiplied the whole thing out. And, at that point, you're done. Which is a lot easier than multiplying out x squared plus 4x 7 times, and then taking the derivative of the corresponding polynomial. And we don't multiply this out, we just leave it in its original grouping. So that's the whole concept of the chain rule. Now I just want to demonstrate another example. So we'll do another example. This one actually is a little easier, but I'm going to do it 3 ways, because let's say f of x equals x squared plus 2x quantity squared. So I have a composite function. I could also multiply it out and use FOIL, or I could use the product rule. So we're going to do it 3 ways and show you get the same answer. Okay, just to show you the 3 ways that we know at this point. So the first way is I'm just going to multiply this out. Using FOIL, so I'll get x to the 4th plus 4x cubed plus 4x squared. Okay, so what I did is, multiplied first. Inner and outer are the same, which is 2x cubed, so I have twice that, 4x cubed, and 2x times 2x is 4x squared. So all I'm doing is just rewriting it. I'm not taking the derivative. And then I could take the derivative, f prime of x equals 4x cubed plus 12x squared plus 4x. So that's the derivative. All I did there was use algebra to make it into a polynomial, which then I could take the derivative directly. Okay. The second way I could do that is use the product rule. So second way, product rule. So in that case, I've got x squared plus 2x times x squared plus 2x. So that's, let's call that h of x. So f of x equals the first term, and g of x equals the second term. And then you take the derivative of each part of the product. So you get 2x plus 2, g prime of x is 2x plus 2. And then the product rule says that the derivative of the product is f prime of x times g of x plus f of x times g prime of x. So you stick those in there, 2x plus 2 times x squared plus 2x. So that's my first product. And then I have the same thing again, so I have f of x times 2x plus 2, okay? And then you multiply it out with FOIL, so you'll get 2x cubed plus, let's see what we have, 2x squared plus 4x squared plus 4x. Okay, so if I do FOIL on this, I'll get 2x cubed, 2x squared, 4x squared, and 2x. And then you get it again. So I get plus 2x cubed plus 2x squared plus 4x squared plus 4x. Something's wrong. Oh, I did my derivative wrong over here. That should have been 8x. 4 times 2 is 8. Okay. Realized because I was going to get a different answer here. I can't. So if I add these two together, I'll get 4x cubed. 2 plus 4 is 6. 2 plus 4 is 6. 6 plus 6 is 12. So I get 12x squared. and 4x plus 4x is 8x. So I get the same answer. That's using the product. This is multiplying it out, taking the derivative. But finally, the chain rule. So in the chain rule, you'd start with your, so what were the steps? We said, so f of x equals x squared plus 2x squared. So first thing we do is we identify u of x. U of x equals x squared plus 2x. That's the term in the parentheses. Make sure I use the same steps here. Identify u of x. Okay, identify f of u. So step 2 is identify f of u. So f of u is just u squared. And again, you can always check it by plugging this into there, and you should be back to where you started. I think the third step was just write down the chain rule. The chain rule says that f prime of x equals f prime of u times u prime of x. So step 4 is to take the derivatives of the two parts. So we go up here, the derivative of this is 2u, just like we'd get 2x if we're taking the derivative with respect to x. U prime of x, the derivative of that is 2x is x squared. No, it's 2x plus 2. Right? 2x plus 2. Okay, so that's the derivative of the u part. Again, we're just using things we already know what to do. And then step 5 is to plug it in. So f prime of x equals 2u times 2x plus 2. But just like before, because we've taken this derivative with respect to u, the answer here is in terms of both u and x. So now you have to go back to step 1 and plug in what u of x was, which I always have to do because I forget by the time I get to this part what the heck it was, because it's all the way at the beginning of the problem. So the next part is just to substitute and simplify. So you get 2 times u, which was x squared plus 2x, times u prime of x, which is 2x plus 2. And now we just need to multiply it out. So we'll get 2 times, using FOIL, we get 2x cubed here, plus 4x squared from here, plus 2x squared from here, plus 4x from the last. And you can see what I'm going to get is 4x cubed. 4 plus 2 is 6. 6 times 2 is 12. So I get 12x squared. And 2 times 4 is 8. And I get 8x. And you see, it's the same answer. Okay, so those are just different ways of doing the same problem. They give you the same answer. They're all depending upon what situation. In this case, you know, it took about the same amount of time to do each one. But, you know, if I had that, there are cases where there isn't another way of doing it. Which I will now demonstrate. So I'm going to do one more here, and then take a breather. So let's say I give you the function, the sine of x cubed plus x. So again, that's a composite function. I know the derivative of the sine. I know of x. I know the derivative of x cubed plus x. I don't know the derivative of x sine of x cubed plus x. So we'll ask you guys some questions now. So looking at the previous problem, Kelly, what is u of x for the problem on the right-hand side?
X cubed plus x.
Yes. And notice, so we're going to, u of x equals x cubed plus x. Notice that, this is in parentheses when I did the problem. The first problem I did, this was in parentheses. In this case, I did put parentheses around this so that I knew this was the entire argument. So typically, most of the time, u of x is in parentheses or in the square root of something. Okay, let's see, next part here. So the next question is, what is f of u? So let me see. Elias, what is f of u?
F of u would be sine of u.
Yes, thank you. Okay, step 3, I'll write that down. So this is the chain rule. Okay, so now I need to find f prime of u and u prime of x. So Lexi, what is the derivative of the sine of u? Yes, cosine of u. Yes, okay, so it's the cosine of u. And Asia, what's the derivative of x cubed plus x?
3x squared plus 1.
Yep. 3x squared plus 1. Okay, so then the next step is find f prime of x by plugging in f prime of u, which I'll go ahead and do, sine of u times u prime of x, which is 3x squared plus 1. And then what do I substitute? Let's see. Michaela, what do I substitute in here? Look up at the top. What is it? X cubed plus x? Is that what you said? Yes. Okay. So yeah, we go back to the first part of the problem and we just substitute that in. So you get sine of x cubed plus x times x squared plus 1. And then we just rearrange it. 3x squared plus 1 times the sine of x cubed plus x. So that's it. Okay. So that's how the chain rule works. You just need a lot of practice at it. We're going to do a lot of practice because not only is it important in taking derivatives, but the whole concept of breaking a function up into two parts is it's important in integrals as well. Yes?
In step number 5, why is it sine of u?
Because I wrote it down wrong. That's why you're here, to keep me straight. So yeah, it should have been, I don't know why I did that. Cosine. Thank you for pointing that out. Okay. Now, here's a little background of the whole, that's how you do it. That's the mechanics of doing it. One way it's kind of described is, when you take dy dx, so you're taking the derivative of y with respect to x. What you can do is you can say, take the derivative of y with respect to some intermediate variable u, and then multiply that by the derivative of u with respect to x. And even though they're not, up to this point, they're not really fractions, you can kind of think of them as fractions in this case. If you were dealing with fractions, you'd say, oh, I can cancel these two out, and it simplifies back to what I started. But that's the basic concept, is you're introducing this intermediate variable, u, so that you can break it up into two parts that you do know how to solve. That's actually a lot of calculus is, we don't, if I show you the list of equations, well, it's in this. So it seems like a lot, right? But for a whole 5-hour class for a whole year, these are the derivative equations right there on the top. And we've got about 40% of them already figured out. And we're only in the 4th week. But these are, and actually all of this stuff comes from what we did in section 2, which was use the limit definition to figure out what the derivative of a polynomial was and the derivative of the trig functions, sine and cosine. From that, we were able to use the quotient rule to figure out the other trig functions, which are on here. What else did we learn how to do so far? We learned about the product rule, which we used the limit definition to define. We can do the same thing with the quotient rule, but we didn't spend the time doing that. So, we start with a very simple few things, but we can expand it into not just these things, but it's not an infinite maybe it is an infinite number of different combinations of functions that we can end up taking the derivative of, which again, the whole idea of the derivative is to find the slope of the tangent line. And that is important in things like velocity and acceleration in physics, and also in electricity, electronics, all those kinds of things when you get to that point. Calculus is the building block of higher level math. Okay, so I'm going to give you guys a problem to work on, just to think about. And I'm trying to make it so it's not too much of a step beyond something that you know how to do, but it is a little challenging. So I'm going to do the square root part here, okay? And I'm going to put it in parentheses just so you know. So and I'm going to delete this page so you can see what we did on the last one. So let's see how far you can get by yourself. Which are previous examples. So remember, what you're going to do is you're going to replace the square root with a fractional exponent. So if you haven't figured that out yet, you're probably not going to figure it out. So I would rewrite the original equation as this. Okay. Well, I wouldn't suggest it. You have to do that. Say, you know anything about that?
He's still pretty sick.
Is he sick? Okay. I don't know if he was sick or give it up.
Probably a little bit.
Yeah, that's what I wondered. So that's the square root. So you gotta rewrite the fraction of this. Subtract. So it's 1/2 u. So that's going to be u. So it's f of u. So then once you do this, you call it back in. Okay, that's all good. So this is f of u. So you can do power. Subtract one. So that'd be f. Okay, so there's your answer. So, we have u of x, we said was u to the 1/2 power. And pardon me, f of u is u to the 1/2 power. So the derivative using the power rule is going to be 1/2, which is the exponent, times u to the 1/2 minus 1, which subtract 1, which is negative 1/2. So we get u 1/2 u to the minus 1/2 power. Everybody probably got this part. Then you substitute in the two parts, part 4, you do this. Then you go back to step 1 to find out what u is, substitute that in. Then what I did was I moved this to the denominator, so it became positive 1/2, and then I changed it back to a square root. So there's 2 steps there I took. This 2 I put there, and I put this in the numerator. Okay. So what I'm going to do here is this is a assignment for Friday, and this is what you're going to do Thursday. So it's just more practice. And what I'm going to do is I'm going to put a video up, and the first thing I'm going to do is I'm going to go through every problem and specify what f of u is and what u of x is. So I want you to do that yourself, but without going to look at my video. Try it yourself first, and then if you get stuck, then you can look at it. Then you can, and then the second part of the video is I'll work out the rest of each problem. So I want you to, once you know that you've done f of u and u of x correctly, then you can check my result. Notice I have given you an example, which we'll go through here shortly, which has all the steps. I'm not sure it's exactly the same steps that this gave you, but they're pretty close. So we'll just look at it. So we have this problem. It's kind of like what we just did. It's x cubed plus 4x. It's the cube root of that. So yeah, it's slightly different order here, but shows f of u and u of x. You know, you take the derivative, just like we did. In this case, you get 1/3 u to the minus 2/3 for f prime of u. You write out the chain rule. You substitute in the stuff, and then you have that expression in step 4, which is a function of u and x. So you then go back and see what your u of x was. You've already forgotten what it is, and plug that in, and then you simplify. So you can see there's quite a few examples. If you go to the last page, you'll see there's an example of you have to use the product rule and the chain rule. And one key thing here is that, remember, let me just give you an example. If you have the sine to the 4th of x, that's the same as the sine of x to the 4th power. You can't really it doesn't work trying to do it this way. It's better to rewrite it in its a little more complicated form. In this case, if I wanted to identify f of u would be u to the 4th power, because that's what's on the outside of the parentheses, and u of x would be what's inside. So there's a couple that involve the sign raised to a power like the last page. You need to rewrite them as such. And this problem here is a combination of the product rule and the chain rule. So all you have to do is when you're evaluating the derivative of the sine squared, do that separately, and then just plug the result of doing that separately into the product rule. So that's when you add the product rule. It's not that complicated. You just have to find the derivatives of the two parts of the product, but to find the derivatives of the two parts, you might have to use the chain rule. In this case, you do. And the last one we haven't talked about, and I want to hand your tests back now, so you can hold off on the last one. We'll do that in class, okay? So let me get the tests for you here. Let me just stop my recording.